these techniques, and through comparison we'll understand that how FPA will be a better technique. Now let's take a simple application. I've taken this online shopping portal, and there are two actors of this. One is buyer and the seller. And I've taken few very commonly used features of any shopping portal. That is, buyer can search an item. He or she can click the item to get the details of these items, can add that item to the shopping cart, and can place an order of the items in the shopping cart. A seller can add, delete, or modify item. He can generate an inventory report, and he will be informed when an order is placed with the complete order information. Now there is some more information available for a little bit adding a bit complexity, not absolutely become simple. That there is a financial system which is available already, and the tax information is maintained there, and this portal will use the tax information from the same system. It will not maintain its own tax information. Now this one-liner may not be helpful to estimate the project, so we have got some details into that. Now it's quite possible that some places the things may not logically fit, but the idea is to get some details and see that how this technique will work. For searching an item, the buyer will enter the search text and he will get the item name, brief description, picture, price, and discount if available. He can click on the name, and he will get the item number, name, description, that is a detailed description, you can say, price, if it is in the stock or not, mode of payment, maybe by check, by cash, by credit card, by cash on demand, cash on delivery, discount, any kind of thing. Now if you want to add this, you like the item, he can click on the add to cart, and the item will be added to the cart, and all the items in the cart will be displayed to the buyer. And if you want to place the order, he can click on the place order, and he will be asked for the address for billing and shipping. In that it will be he will be asked for name, address, city, for both billing and shipping address separately. And with this information and the item information which is there in the shopping cart, if order will be placed, and he will get the display of the order. Now what the seller can do, the seller can for adding or modifying, he can enter the item number, name, brief description, I think all the information which is required for adding an item, and then as a return he will get the confirmation that the item is added or modified, or he will get an error message. To delete, he will enter the item number to delete, and he will get the name and description will be displayed, and he will confirm the deletion, then it will be deleted. So he will get a confirmation message or an error message. He can click on generate inventory report, and what he will get is the list of item numbers, description, and the quantity in stock. Now when seller will place an order, the information about the name, address, city for billing, as well as shipping for shipping, plus all the information about the item in cart, plus the total value of the order, etc., will be sent to the seller. Now if I put this in one diagram, the total application will look like this. This is a seller who can add, modify, delete an item, add, modify an item. You can generate an inventory report, and there is a search. Buyer can search an item, display the details, add to the cart, and place an order. And now to do these transactions, there are some permanent files, you can say, database files, you can say, database entities, you can say. So there is an item master which contains the item information. There is a cart which contains the information about the items which are added into the cart, and there is an order file which keep the order which was placed. Now there is another system which is called financial system, and the tax rate is another file which will be used by place order functionality. Now let's look at how the function point will work in such a application. The function point, the elements which are involved in function points are something like this. It's a brief summary of the things in function points. So we decide on the type of count. Type of count is something like this application to be developed, to be maintained, or to be enhanced, or the application is there. We need to count the size of the application. Okay, so this either of the three will be we have to select that what is our intention. The second is we need to define the scope of the application. What is inside the application and what is outside of, what is scope of the application, scope of the work, maybe you can say. Better you say scope of the work. The scope of the work may have multiple application or one application. And the third thing is the boundary of the application. This is very important. The boundary of the application means the application we are developing, we have to put a boundary where we can say that what is inside the application which will be developed as part of this application, and which is outside of this boundary which is not part of this application. Now there is another, how we will count this will be depending upon the data function and the transaction functions. Now data functions are nothing but understanding the database entities or the permanent data storage entities which contains data which is required to perform the transaction. So there are two types of entities. One is called internal logical file, another is called external interface file. It is EIF and the ILF. And the transaction, normally the things are divided into three types of transaction. Normally, see, the function point works on how user use the functionality of the application. The basis behind the function point is this, that application is being developed to service someone. Now, how this application service the user, that's what we need to count. So whatever we do whatever we develop as part of this application somehow should be connected to get some input from the user or give some output to the user. So user has to interact with this thing. If any component we create as a part of this application and user does not interact with that part, that is not counted, even if you make it. So everything is the main thing behind the difference between the function point and other technique is that it is completely from the user's point of view. Anything which is not being supplied to the user or user has not demanded is not counted, even if we create it, even if we develop this as a part of the life. So if any functionality which is adding value to the user has demanded, user has agreed upon, that functionality will be added, will be only assessed as part of the estimation. Now when the user will use, it means Either it will provide an input to keep in the application, or it will use that provided information in a different form, getting the output from the application. So mainly there are two types of operations are happening. Either some input is provided by the user or external entities which are interacting with this system, or they are getting something out of the system. If system does internally something, that is normally not part of the estimation. Now the third is the general system characteristics. General system characteristics are actually taking care of the performance and the environment factors which applies across all the functions. So they are basically, you can say, addressing the non-functional requirement. So data function and transaction functions address the functional requirements, while the general system characteristics address the non-functional requirements. Broadly, we can say this. Now to understand this, let's look at this diagram. This one diagram, I think, will decently explain what a function point is. As I said, that everything is based on how user perceive this application, and that's how this application will be counted. So there will be a consensus between the developing team and the user. There should be no difference of opinion between these two people. If user has something, he has to provide it to the development team and get concurrence, and the development has something, some technical or something non-technical, has to propose it to a user and get the concurrence. Now look at this diagram. Here is a user which provides some input, which we normally say external input, and what it does, this application, to maintain this information inside the application, which is provided by the user because it's important for the application, we have a database entity which is where the things will be stored, and normally we call internal logical file. Now other things are output. So output can be in the form of EQ or in the form of EO, that is external output or external query. The user, these are the two things which user take this data. So it inputs this data and receive the data in different form. All there will be either EO or EQ. Now what is an EQ? EQ is something which is fetched from the database and provided to the user with some sorting or indexing kind of thing, some kind of decoration thing. There is no operation happen on the project, on the data. So if data is fetched without any operation on that data is provided to the user, it is called EQ. While if data is fetched and some calculation happen, some operations happen, and then the data is provided to the user, then it is an EO. It's a definition of EO and EQ. Both are output. So when we say EQ, it means the data is not processed. When we say EO, the data is processed before providing it to the user. Now this EO, EI and EQ called transaction functions, while this ILF and EIF are called data functions. Now what is EIF? EIF is one database entity which is from where some information is required by one of the transaction in this application, but it is external to this application, our application. This is the boundary of the application, and this text rate are outside of this application. What is inside and what is outside? Inside database entities are the data entities which are owned by this application. It means owned by means this application can modify this data. So if any file is there which this application can modify is an ILF, and any application which this application cannot modify but you can use the data is an EIF, that is external to this application. Therefore, this is not owned by this application. That's why, because it is owned by some other application, that application doesn't allow any other application to update this data. However, read-only information is available, so this application can use this data to use in the transaction and do some calculation and provide the data to the user. So this is called external interface file. Now, when we go in details, we can see that what exactly then EIF and how sometimes EI and EIF can be confusing, and we need to figure it out in what cases we need to. They are not. They are separate. They are not same. So there are some confusion which I have often observed. Okay, I hope this will be clear. So these are called data functions. Now look at the same diagram now. So if you see this, this is an application, and if you see this is an application boundary for us, and if things are coming inside, it's an EI, and since it's going outside is the EO. Okay, now let's look at this. Normally what happens, how the process goes of this function point counting. When we understood, first we determine the type of count. Is this a development type, it is a maintenance type, or it is an application type? Then we define the scope of the estimation and boundary of the application. Scope of the estimation and boundary of the application. This requires little explanation, but we don't have time to explain this right now. Now after this, we'll go to count the data function and the transaction function. You can count either data function first or transaction function first. It's independent as such. Once we count the data function and transaction function, we get unadjusted function point count. By adding the impact of this, so when we count this function point, they are called unadjusted function point count. So we will get unadjusted function point count for the application. Then we determine the value adjustment factor, which is through general system characteristics. So we assess that how general system characteristics are impacting the count, and based on that we calculate the value adjustment factor, and then we multiply this with the unadjusted function point count to get the adjusted function point count, which is the final outcome of the function point. And now which is the size of the application. Now to get the efforts, we multiply this adjusted function point count with the productivity of the team, of the resource, or of the, what is the productivity of the team. Then we multiply the productivity of the team, that how many hours per function point, and then we get the person hour, how many days per function point, and we'll get the total efforts. So first we count the size, and then we count the efforts. Now sizing is important here, that first we are calculating the size. In some of the techniques, the size is not calculated. Directly efforts we calculate. It is something like that. If you ask a painter to come to your home and paint the wall of your home, then what he normally does, that he go around the home and measure the surface he has to paint. Now if he comes out with say, okay, the 5,000 square feet of surface he has to paint, that is what the size of the work. Now depending upon what is the productivity of his people, that how many square foot of wall a person can paint, he will depending upon how much time is available, he will deploy the number of people, or he will calculate the total efforts, that my people can paint 10 square foot of wall in a day. Then he will say, okay, the total effort is this much. So this goes exactly that way. Now let's apply this here in our application. So this add and modify, they are the data which is coming from the seller and getting updated into the item master. So first because there are two operations, add and modify, so we have two EIs. EI means there is always an update in an ILF. This is always. Now delete is also updating the things in the ILF, therefore it is an input. Now inventory report is a data which will be read from this item master and will be provided to the seller, and therefore it is an EQ. Now inform the order of sale, because the order contains some calculation, the sum, etc., it becomes an EO. And so get the information from here and provide this. Now based on this, the search item is an EQ because it will provide a search item, and what is the intent of the buyer? To get the information from the system, that is such a item available here or not. If he clicks on the item, again the intent of the buyer is to fetch more information about this item. Okay, so sometimes if it is confusing, we need to go what is the primary intent of the user. You are inputting something and you are taking something out from the system, and sometimes people get confused, it's an input or output. So the things goes like this, that you look at the intent of the user. If user intent is to fetch the data, then it is an output or EQ or EO. If it is the intent is to provide some information to the system, then it is an EI. Now add to the cart means adding some information to the shopping cart is an input, because that will get updated into the ILF. Now placing an order requires a tax rates, what is there in the cart, and then put this order into the order file, which is ILF. So ultimately this information is also to be update the system with the new order. Right? This is the boundary of the application, and fortunately the scope of the counting is also the same. Because this is an external file, it will be called EIF, because this application cannot write here. You can only write this, and this. So basically we can say there are 3 ILF, 1 EIF, 2 plus 1, 4, 4, 4, 4, 5, and 6 EIs, 1, 2, 3 EQs, and 1 EO. Right? Now let's see that how we will assess the complexity of this application. To assess the complexity of the application, we see that what is the exchange happening between the user and the system. What is the exchange happening between user and the system? What data elements have entered into the system or exited from the system? That's why I say boundary is very important. What data elements have been gone out of the system and come into the system? And if there is a subgrouping among them. So in the transaction functions, we just see how many data files it is touching. The data elements it is touching. Data function it is touching. The files it is referring to. How many files it is referring to. So if you say search item has the search text which is entered, and item name, brief description, picture, price, discount, submit is there, are the things which will be output to the systems. Okay, so search text is come into the system, and these 6 items get out of the system, will be displayed to the user. In that manner, there are 7 data elements are involved in this transaction, and it only accessed through the item master. So one file is involved. Because one file is involved, we go to the FTR, that is one FTR, file type reference. FTR stands for file type reference, and DET stands for data element type. So data element type means every field is a data element type, and every file reference is a file type reference. So here one file and 7 data elements. If we go display the details, if we count 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 elements. Now if you see, submit is an element, so invoking the operation is an element that is also required. So submitting means invoking the function is also an element which is counted here. So submitting is also counted. So 7 data element and 1 file type reference. Now add to the cart their item master, where the cart where the item information comes, and the cart where the item information goes. So there are 2 files which are, there are 2 file types which are referenced here, and what are the items here which are displayed to the user? The item number, name, quantity, price, discount, net price, and the submit. Okay, you invoke this system, add to the cart. Okay, so there are 2 file type references and 1, 2, 3, 4, 5, 6, 7 elements, 7 elements here. Now placing an order means getting the name, address and city for billing as well as for shipping. So 1, 2, 3 and 1, 2, 3 for shipping. So 6 elements, 7, 8, 9, 10, 11, 12 and 13. The total value of the order. It's a calculated field. It's not a field, but it is exiting from the application, that is being displayed to the user, and therefore this is also an element. Okay, so there are 13 elements, and yeah, the FTR is the file type reference. File type reference. Okay, so and there are 1, 2 and 3. Taking the order file where the order is placed, cart from where the information about the items are pulled, and the tax rate where the tax related information is pulled. So 3 file type reference. Now let's go to the other transactions. So add, modify items. So there are 2 EIs, and every EI has 1 file type reference and 10 DETs. Okay, delete elements. These items are involved in the transaction. See, the confirm and error message is also come as a one element. So providing a message to the user is also an element. So everything which is every interaction which is happening with the user is being counted here. So 1 and 5, because only 1 file is touched. Generate the inventory report, only 1 file is touched, and 4 elements here. And in the order information, the name, address, city for billing, and name, address, city for this 6, 7, 8, 9, 10, 13, and the 1 file only order which is fetched here, and that is 1. Okay, now look at the data element type. Data element type have 2 things. One is data function have 2 type of things which are involved, is the DET and the RET. DET is data element type and the RET is record element type. The record element type is a subgroup between in the same file. So file is same, the one ILF, but there are subgroup in that ILF. So here is all information about the item only, so there is only one RET, and there are 9 9 fields, so 9 DETs. Card has user login which attached where the item number will be attached, so that you know that which item this person has ordered, and the quantity. This is what is actually there. Everything else is fetched from the item master. So 3 DETs and 1 RET. Now here in order, you see there are 3 subgrouping. One is billing information and the shipping information. Now billing information, shipping information, how they are separate? Because shipping information may be missing. The person may or may not enter shipping information. In case he does not enter shipping information, billing information will be used as shipping information. So it is separate from billing information. It is optional. And the item numbers can be multiple. There could be multiple items in the card. While the billing information will always be only same, only one. So therefore, billing information make a one subgroup, shipping information make another subgroup, and the item details give another subgroup. Therefore, there are 3 RETs here and 13 elements. And the tax rate, there is 2 elements and 1 RETs. Let's see how we're going to calculate the function points for this. Look at this, that how we will how the unadjusted function point contribution will be counted. Look at the below. These are the rules. These are the rules. You can say they're magic figures. They are based on the study of several projects, and therefore these magic figures are concluded basically after the research. So this is what Mr. Albrecht actually come out with. So in an EI case, if there is a 1 FTR and 1 to 4 element, it will be low. 5 to 15 element, it will be low. 1 FTR with more than 15 elements will be average. 2 FTR more than 4 element will be average, and more than 15 elements will be high. If there are 3 FTRs, it will be minimum will be average. If it is more than 4 elements, it will be high. Now in case of EO and EQ, it is a little different than this. Okay. Now based on this formula, we will come out with the complexity. So it is an EQ 1 FTR 7 elements. EQ 1 FTR 7 elements low. Display details. EQ 1 FTR 7 elements low. Add to cart 2 FTR 7 elements. 2 FTRs, it is EI. So 2 FTR and 7 elements here, average. Come average. Place order EI 3 FTRs and 13 elements. 3 FTR and 13 elements come out to be high. Okay, then it is add modify items, the EI 1 FTR and 10 elements. So 1 FTR and 10 DETs will be low because 2 lows as such. Okay, delete element, again it is low. The seller generate an inventory report 1.4 EQ is low, and EO 113 1 and 13 will be here is low. So all are low except this is average and this is high. Now based on this, you see EI and EQ contribute low. EI EQ contribute 3 unadjusted function point count, that is UFPs. EI EQ average contribute 4 UFPs and high contribute 6, while the EO is 4, 5, 7. So low EQ is 3, low EQ is 3, average EI, average EI 4, high EI is 6. The low EI will be 3, but there are 2, so 2 into 3 is 6. Now low EI is 3, low EQ is 3, low EO is 4. And the total come out to be 32. So total transaction function contribute 32 unadjusted function point, UFPs. Now look at the data functions. The data functions have like This is the rules for data functions. So ILF or EIF, 1 RET and up to 50 DETs it is low, but more than 50 DETs average. With 2 to 5 RETs, after 90s it is average, after 50 it is high, and with 6 or more RETs it is average, and after 19 DETs it is high. Now let's see, 1.9 is low, 1.3 is low, 3.13, the 3 and 13 again it is low, tax rate 1.2 is low. And what a low ILF contributes? Low ILF contributes 7 UFPs. So low ILF 7, 7 and 7. While EIF contributes 5. So it is 5 and it becomes 26. The total UFPs 26 contributed by data function. Now look at the total, look at the environmental, the performance or the non-functional requirement. I will not go into details because they need to be understood. What I say, it's an average. Let's consider it's an average system. The VAF, the value adjustment factor, is calculated with this formula, where TDI is a total degree of influence by these things. You can give value from 1 to 5 here, 1 to 5 for every 0 to 5, 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 and then make it total. The total will be the total degree of influence will be here. Now minimum value for this is 0 and maximum value is 70. Now this can influence the unadjusted function point by plus minus 35%. So if it is 0, it will reduce to 35%. If it is 70, it will increase the or inflate the UFPs to 35%. We consider 35 here to come out with a value adjustment factor as 1. We do not want, because we don't have much time, that's why we are just keeping the value adjustment factor as 1. So let's see how it will be counted. So UFPs of data function plus UFP of transaction functions, it is 32 plus 26 becomes 58 UFPs for this application. Now adjusted function point count equal to UFPs into VAF. Now VAF is 1, therefore the UFPs and AFPs are all same. Right? Now to get the efforts for the programming language Java, these are normally, there are benchmark figures which are published by very many organizations, and you can have your own organization's benchmark figures also. I have taken one such survey, one such benchmark figure, which shows that Java has every function point required 10.6 hours of a programmer, or total efforts basically, to address the one function point. So what we do, we will multiply this adjusted function point count with the productivity to get the total efforts. So if we multiply this, we get 614.8 person hours. Sorry, it is not per hour, it is person hours. Therefore it becomes, divided by 8 will become 76.85 person days, approximately 77 person days of efforts for this application. Right? Okay, how to 70? If all are 5, there are 14. If all are 5, there are 14. So 14 into 5 is equal to 70. And therefore maximum can be 70. If all are 0, then it will be 0. I hope this is fine. Okay, now let's look at the same application we estimate using a WBS. It's fairly simple in WBS. What we do, for each and every functionality which we explained in the first slide, Buyer can search an item. It's a simple functionality. Buyer can see details by clicking an element. This is a medium. This is simple. Adding an item to the shopping cart is simple, but placing an order is a complex functionality. Okay. Seller add, delete, modify. Maybe add, modify are medium, and the delete is simple. Seller can generate an inventory report, which is called as medium, maybe could be simple also, depending upon the expert's assessment. Now, what is in WBS? That WBS we break down the whole application into functionalities, and then an expert sit there and understand, and using his judgment, using his experience and knowledge, he decide that it is a simple, complex, or medium. Now, there is no number for the external system, so it is there. What I have taken efforts, it could be debatable, it could be like different organization can follow different. What I say that cut effort, the coding and unit testing efforts, code and unit testing effort only. So for simple to do the coding and unit testing, it requires 1 day. For a medium, requires 3 days. For a complex, it requires 5 days. And that's how I have added all these here. 2 medium, 2 into 3, 1 simple, 1 into 1. Medium 3, complex 5 will come out with the 25% days of effort for code and unit testing. Now, if I consider that code and unit testing is 35% of the total efforts, then what I will do, I will divide this 25 by 35.35 to get the total efforts of the application. If coding and unit testing efforts are 35% of the complete application, dividing this coding and unit testing effort by 0.35 will give us the total efforts of the application, which come out to be 71%, near to that, little lower than what we estimated in function point. But it is fairly simple. You see, we took about 30-40 minutes to calculate through function point. It took only a couple of minutes, just 5 minutes. Now let's look at the use case points, how the use case point goes. In the use case point, what we identified 3 use cases here. One is purchase an item. If the purchase an item is a use case, what the buyer will do, search an item, see the details of that, add to the shopping cart, and order and place an order. Maintain the store. The seller can add, modify, and delete the items, right? And reporting is another use case, which says there are 2 reports. One is the inventory report, other is the report which is providing the order information to the seller. Okay. Now, how the complexity come out to be, I think this is not correct. This is actually complex. Oh, medium, average. Okay, this is average. So there are 2 ways, 2 guidelines are giving to understand the complexity. One is transaction based, that if they are transaction mode 1 to 3, then it is simple. 4 to 7 transaction average, more than 8 transactions, 8 or more are complex. Or there is another guideline given that if there is simple UI or processing and touches only one database entity, it is simple. If there is a moderate UI and simple processing, we have not written the processing every time. So moderate UI or moderate processing, then or touches 2 or more databases, it will be average. If it is a complex UI and complex processing and touches 2 or more database entities, it would be complex. I think it should be 3. I'm not very sure. It could be 3 also. Now, based on this information, though this definition is pretty vague as such, but this is what the guidelines given. So based on this, we will go with the transaction ones. Even this is more or less same. So this come out to be an average complexity. This come out to be, because there are 3 transactions, come out to be a simple one. And this reporting will also come out to be a simple one, though the order placement is a complex transaction. Now that's the drawback with the use case point, that it is not getting into complexity of the transaction. Though here the guidelines are this, but these guidelines are like not very so precise as such. So we go with this definition and put this average, simple and simple. So this 5 is not 5, this 5 is here. Okay, now what it does is simple give a weight of 5, the average give weight of 10 and the complex 15. Now it is average is 10, simple is 5, and the simple is 5. Total come out to be 20, and this is called unadjusted use case weight. Unadjusted use case weight. Now in the use case point, we see the complexity of the user as well. And there are two users here, buyer, seller, and three users, because there is an interaction outside. So there is a financial system as well, because it provides the tax information. Now the guidelines which are given here is that if it is a human, then it is a complex user. A human is a complex user, while an external system must interact with the system as a well-defined API. It's one. If it is a specific communication channel protocol, then it is average. Here it is simple API, so it will take simple. Buyer and seller are human, so it will be complex. So this will contribute 3, this will contribute 1. So for buyer, the unadjusted weight for actor, user or actor, it is 3, 3 is 7. So unadjusted actor weight is 7. Now there are two more things in use case point which is actually assessed, which is called technical complexity factor, which is similar to the general system characteristic of function point. So use case point is a little hybrid kind of thing, which is something taken from WPS and something taken from the FP. So technical complexity basically is more or less similar to general system characteristic, while environmental factor, complexity factor come for that how good the team is. So this is a good part, that your productivity will get influenced with this environmental complexity factor. That if your team is new, the environmental complexity could be higher, and it will inflate the efforts. So this will adjust some productivity which you apply. Now how you calculate the use case points? The unadjusted use case weight, unadjusted actor weight, the sum of this into TCF into ECF, TCF and ECF. Because for simplicity here, looking at the time, we have we have taken them as 1/1. So UUCW is 15 and it's not 15, it is 20. I'm sorry, I think this is getting too many mistakes in this. So 20 plus 7 is equal to 27. So the sum is right. Okay, now total efforts will be again the same way that we have calculated in TCF, and range will go similar. The TCF has the similar range like general system characteristic. Environmental complexity, I'm not really sure right now. I need to look into. Now total efforts will come out to be this is called size, use case point, this is called size of the software. So size of the software into 25 is taken as a average kind of productivity. The guideline is somewhat between 20 to 28. The guideline which is given here is 20 to 28. Okay. Now I have taken a little average kind of things between 20 and 28, that's 25, which come out to be 675 person hours, which come out to be 84.4% days. Is a considerably high than what we estimated using work breakdown structure and WBS technique and the function point techniques. And therefore, and this is what is normally observed also, that use case point estimates are normally higher than the other techniques which are like function point or some other techniques, the WBS or other techniques. And this come out to be 84%. Now the thing, what is the difference between these three approaches? Now what happens in the function point? Function point goes for every function, every feature which user is using, and count only those features which user is using or user has demanded. So it is totally user focused. While WBS is completely effort based, so it is completely development team focused. So how much efforts will go? So what happens in the WBS? The lot of like if the team is new and is take more time, then that learning efforts of the team will also get factored into the efforts, and which the training the people is actually what the vendor organization should invest into. Actually the client end up investing into that, because we demand the client should hope to pay for the training of the resources as well, because they are good. The second thing is that there is no rule for coming out with the simple, medium, complex. Okay, it is completely depend upon the expert. So different expert will assess them differently, and there is a fair chances that different expert will come out with the estimates which may be varying a lot. So there is no standard in that. Now this cut efforts, these efforts will also depend upon, but up to a certain extent you can either like these are there is no industry benchmark for them. You can only have to look into your organization that how you are performing and assess these efforts. There is no industry benchmark for the expert judgment in this, or the how much effort you should count. Somewhere it could be 1, 2, 3. Somewhere it could be 2, 3, 4. Somewhere it could be 1, 3, 5, depending upon the individual organization or even in the project. So here the estimates varies a lot and very much depend upon the who is doing the estimates. Now in the function point, if you see, there is a well-defined rules that how to define the complexity, and complexity depends upon how much gravity is there in the transaction, how many data elements are involved in the transactions, what is the weight of the overall transaction, and every transaction is being measured, every interaction is being measured here, plus whatever data we require or whatever data we store to perform those transactions will also get assessed. So these are the transactions, and to perform these transactions we need this data. This data is required because we need to perform those transactions. So this data depends upon how user is using the system, and therefore these data elements are also get assessed. And here also these are well-defined rules, and this is what make FP a very standard one. Because of the well-defined rules, 10 people do the same estimate, more or less come out with the similar estimates. Now just to let you know that unadjusted function point is the NC standard, American National Standard. So function point is accepted as a estimation, the standard estimation technique by the American National Standard. but they do not endorse general system characteristics. They say they are only influencing efforts, and I agree with this opinion that actual size is come out with the data function and the transaction function, and general system characteristics are basically depending upon the complexity of the system. Actually, they are they influence the overall basically the efforts, not the size of the application. I give I want to give application, one understanding. Give me a moment, and I will give you a little understanding and analogy of a painting the home. See what happens in. Let me just show you what happens in a normal case. Suppose there is a room to be painted. Okay. Now there is a size of this room. Okay, this is the size of this room, and suppose it is around, let's say, 100 square feet. Okay, now 100 square feet, and if he has a 10 square feet per day of efforts, then it will take 10 days to complete, right? It will take 10 days to complete. Now if it is one layer, so one is the size, another is the productivity, and other is the what kind of quality you want, what kind of additional work is there. Additional work is that you want one layer, two layers, you want absolutely evenness in the wall. So maybe a putty is layered first, and then you need another layer. And you say, okay, I need 2 layers of coating, and what kind of paint you want to use. So there are other factors also, that number of layers and the paint, quality of the paint also factor. Paint, because some paints take more time to paint than other paints, and the number of layer will increase, the effort will increase. Now here is the same, simply is here is that the UFP are actually the size, while general system characteristic are something like additional things, like you say I need the response time within milliseconds. The UI should be very, very good. Now UI should be very, very good is not going to change your FPs, but it will increase your efforts, like increasing number of layers will increase your efforts. And this is something like a productivity of the person to address one FP. So therefore LC has not taken this as a part of the functional size of the software. So they have accepted only unadjusted function point as the real size of the application, while the FPUG has continued with his original definition that after applying GSCs in the UFP, whatever AFP we get, it is the real size of the application. So there is a difference of opinion in American National Standard and the FPUG. Now here the productivity can be like, because this is a standard practice, is an industry standard, there are couple of organizations keep publishing the benchmark data. So if there is no benchmark data for your application, if your organization, you can get some industry benchmark, start from there and develop your own benchmark over a period of time, and then your efforts will be good. So well-defined rule standard practices, benchmark available, make it is a kind of win-win scenario. While in the WBS, the absence of the well-defined rule, leaving the things to the assessment of the people, and people vary a lot from person to person, the opinion varies a lot, chances of varying this lot are quite high. Also, this assessment is also important. So therefore the assessment could vary a lot here. Now in the UCPs, there is a hybrid approach. Here, though it is based on use cases and the transaction and the interaction with the actor is considered here, UCP does not go into details of each transaction, and does not estimate each transaction, but estimate a complete use case, which is a clubbing of the transaction. And therefore, if there is a three transactions here. If I add a view transaction here, view data. Now view is going to be another simple one, right? But this will maintain the store as complex use case. Now here, if you say placing an order and generating an order, despite they are complex, here it is complex. If you add another complex the transaction here, it most probably will remain average. Here, despite having a complex transaction, it is still come out to be a simple one. And this kind of thing actually making it little varying information and sometimes not addressing the real complexity. But the advantage of WBS and use case point both is that they can be done very quickly. It does not take much time. Only thing is that you should document the requirements into use cases. And WBS, even that is not required. So they are very quick, can be done easily, but they are not as accurate or as good as you may be looking for. Function point is far better in that sense. Let's look at the comparison of these. I have added some comparisons here. Now this comparison could be subjective. This is based on my opinion and maybe the books I have gone through. So what the blue is neutral, the green is I will say is a real good part on that side, a winning feature. Red is which is bringing it down, this estimation technique, and amber is a slightly downside. But red is a clear-cut downside, and this is green is an upside, and the blue is neutral. So what FPA does, estimate the size in FPs. WBS estimate the effort, and it also is the size, not the size. Here it is efforts. Now adjust the size for the performance and environmental factor, which is a winning. However, there is these factors are involved in the expert's judgment itself. This could be a little risky. So different people are a risk taker will go aggressive and risk averser will go passive. Now this is also a winner because it's also, and this technical complexity and environmental complexity are adjusted there. That is a good part in that. This is independent of technology. This is also independent only because we are assessing the size, the functionality. We are assessing the size. The only productivity which is dependent on the technology. So till the time you apply the technology, the size is remain same. If you want to do the same application in .NET, just multiply the productivity figure of .NET and you will get the efforts in .NET. But this is a technology opinion. You have to estimate based on the technology. You must know the technology before estimation. Estimate the functionality being delivered to the user. Estimate the efforts involved in providing the functionality, which normally sometimes like learning efforts or the team productivity is not high. That is also inflate the efforts, which customer end up paying it. estimate the user interaction with system with and what operations are done. So it's a neutral thing. It's not a very positive thing aside in that, but it's a neutral thing. Here the well-defined rules for assessing the complexity, that is the real winner of FP. There is no rules. This is a real drawback here. And there are rules here, but rules are a little vague. They are not so precise. They are vague. Every individual transaction is measured for complexity. Here the transaction may be clubbed depending upon the assessment of the expert judgment. How detailed he goes into WBS, it depends upon the expert. Now this is a little drawback here because the individual transaction we are not getting into, and that may not be a very good idea as such. Proven method and industry standard, and therefore the benchmarks are available, and this is, though the WBS is the simplest and the oldest method, but complexity assessments are, but issues are there. UCP is not in that much of use, so we do not know that it is not an industry standard as of now. Moreover, the Gustav, who actually invented UCP actually, is all before making, when he was doing UCP at that time also he appreciated FPA and therefore taken a lot of things from FPA. But UCP is quick. Now FPA need training and some experience before a person use this method. Now this is a little drawback on the FPA side, because if you are not trained, you are not experienced little bit, it is difficult for you to apply FPA. WBS, it requires, it's only expert can do. If a non-expert will do, it will mess up the whole thing. UCP does not require much training or things. A little training will work. FPA, there are many circumstances, many chances, many instances of client, because being an industry standard, client may be mandating or enforcing this on the vendor. Here I have seen the most of the time the client and vendor get into the trouble or get into the discussions because client can always challenge the expertise unless client is trusting the expert altogether, and he knows who is the expert and he trusts that. Otherwise they are challenged. Here, because the rules are vague, client may ask for more details. That could be little painful. Now here there is a myth, it can be used for latest, it cannot be used for latest technology. That is a myth, but that will a drawback, clear drawback on the things, because that is a myth which is prevailing around and which is stopping people to take this up. This is a very common step. Wherever I go, there are always some people who will say, no, it doesn't apply to new technologies, which is not the case here because it is all related to the functionality. WBS is very easy to use. That's a real gain, and that's what making it popular. And WBS is popular because it is very easy to use and can be applied to any type of software, and even FPA can be applied, but it's very easy to use. UCP is also easy to use as such. It could be green also, not blue as such. Can be applied to any software project, yes. Can be applied to any software project, WBS also, right. UCP can also be applied to any software, but the only requirement is that the requirements have to be expressed in use cases. If the use cases requirement, and you need to wait till use cases are ready. Can be early in the cycle, can be used early in the cycle. So there, the method I explained to you is little required lot of details, that how many DETs, how many FTRs, etc. But when you are bidding for a project, when you are starting a project, you may not know all this information. So there are quick FP counting techniques which can be used in the beginning, for which you don't need those DETs or FTR as such. Can be applied, can be used anytime as such. WBS can be used at any time, but early estimates are vary a lot. Early estimate could be little vague as such. It can be used early in the cycle, but difficult to use before requirement get captured in the use case. Actually, this is a winning point for it, that it can be used early in the cycle. But the thing is that you see that the use case should be ready. You have to prepare some use cases for that, even in the beginning time. That's why it is slightly a drawback kind. Productivity is based on historical data, that is parametric. That is a formula which is from the previous data. We come out with a formula of productivity kind of things, and all the magic figures you saw, they're all are due to parametric, due to research, and through using the research we are coming out with some formulas which can be applied on to estimate the software. Now here the productivity is understanding of the expert, and mostly it goes analogous. Analogous means similar to the previous project. So if we have done a similar project earlier, our estimates are better and the productivity will be high. And if we have not done better, like similar kind of project earlier, normally you see we use WBS, and first project with the first client is always create trouble. Adjust the productivity by applying the environmental factor. That is one of the winning thing here. Now if you see the number of greens and number of reds and number of ambers and blue, you can say that FPA is the best technique as such, but as I said, this drawback actually pull it down. But with some training you will be very good in the project, because your estimates will be much more predictable and much more in control. We use WBS because it is easy to use, but it always create problems because they vary a lot. And UCP is not so much in use, but some places it is used and found fairly okay. It is accepted by the experts that UCP estimates are normally higher than the other estimates. I've covered what I decided to cover here. If you have any questions, blue are neutral. Blue are neutral. If you have any questions, I will be happy to take those questions and answer. Let me open the question panel so that I can look at the questions. How can we accommodate engineering activities like reviews and rework? Okay. See, what the estimates you come out with FPA or UCP are the total estimates. Now based on that, you have to distribute into different phases like requirement design things. Now reviews and rework, these are part of the, not the estimate, but actually the your improvement path. You have to see that at what level of review efforts you are putting into the system, and how much you can improve on. So reviews and rework, these are always a challenge, and initially they are high, but what these should always be on the target to improve the overall productivity. So they are not related to estimate, but they are related to that how much, where we stand today and how much improvement we can do in next 3 months, next 6 months or next year. So they should be minimized. Minimized means optimized actually. You cannot minimize them. Review, at least the review, which are appraisal efforts, to be optimized, and rework should be minimized. You can bring it as low as 0 if possible. Normally it is not. Currently this is very poor. Most of the projects normally show very poor. If 5 to 10% of rework is normally considered okay. Anything like I think 10% is considered okay. Less than 10% look appear good. Less than 5% are good, actually real good. Review efforts should be somewhat between 15 to 20% of the efforts, the coding efforts. As you told, submit button is a DET. Yes, submit button is a DET. Using function point estimates are accurate. Okay. Yes, submit button is see, a DET is counted for invoking the function. So there is a function, and for invoking the function, we there is some mechanism. We count one DET. Now, even if there are 10 ways to invoke the system, invoke the function, we still count only one DET. So DET is for invoking the function. If you have F2 also to submit the form, even then it is one DET. 2, 3, 4 submit ways of submitting, but only one DET. That is the rule basically. And we do not go in too much of details because they do not affect too much. If you go into very minor and changes, only then it impact a lot. Because DETs going little up and down do not make much changes in the overall efforts. Using function point estimates are accurate, but time taking, is it not? Yes, they takes more time comparing to the other techniques. Like comparing WBS, yes, it takes time. So you should accommodate, you should budget for that. But I am sure you take it that whatever time you spend for FPA, because of FPA you will save much more time. And if you take WBS, they will be done quickly, but you will end up wasting a lot of time because your estimates will not be accurate. So overall, if you see, you will going to save the time. But that you need to see that I am investing today and going to save tomorrow. That's the approach which we need to take. But they're going to take more time, definitely. The process is a little longer. Green is good feature, red is bad, amber is slightly bad, blue is neutral, is a statement, you can say. Is neither good bad. Is reset button on next button also a DET? Reset, if it is a different function, then it is a DET. Reset means blank, creating like whatever you have filled up, clean it up. I think it should be a DET. Yes, it should be a DET. PERT is applied on WPS to improvise and also to assess risk. Can FP address this? FP does not use PERT. Actually, the PERT is mainly used for WPS, and PERT is some up to certain extent mitigate the risk of some bias by the expert. It not completely address this, but it definitely like reduce the risk involved in because of the expert's bias. So it reduces the expert's bias basically. The PERT, so PERT is definitely, whenever you use WPS, I advise that you use PERT so that your estimates are better basically. But it does not totally remove the bias of expert. Bias of expert is still remain there. It will still be there. Up to certain extent it reduces. For every type of estimate, customer has few points not to accept. What would be an appropriate answer as per you if customer raises concern on the parametric data? Okay. You will not face this problem with function point because function point is a standard and everybody knows how it is done and what is the way to do. So this problem, if you use the function point, this problem is automatically get resolved. Now, most of the challenge come on WBS and on UCPs. And sometimes the problem is the customer can challenge you on the productivity. He can tell you that, okay, function point size is fine, I am okay with this, but your productivity, what you are showing is low. You should have a higher productivity. He may bring some data somewhere. They say it is better than your productivity is lower than the industry standard, and I think this is a challenge with each and every organization to improve the productivity and come to a benchmark. So if an industry benchmark is there and your productivity is lower than that, customer is going to challenge you, and I think you need to address this. How are you going to address this? I'm not very sure that how to address such a thing, because it is very specific to the organization. But you have to say that, okay, the kind of it's very difficult to explain to the client, but I think you have to bring some data from your organization and say that this is what we do, and therefore our quality will be better, or the people or the industry benchmark is with the average quality, our quality will be better. But in that case, you have to demonstrate that your quality is better and you will provide better quality. So, but in the case of WBS and UCP, the customer can challenge, especially in WBS, the customer normally challenge. And what I have done is, in one of the incidents where we were finding it difficult, I put up all the WBS estimates. I put lot of detailed remark on each and every line, that why we have come out this functionality as complex or medium or simple. And I give that sheet. Normally the estimation sheet is not transparent, but I made it transparent to customer, because transparency will only bring the trust. So I say this is a completely honest thing. We have used these things to do the estimates. You take it and you estimate. And virtually he estimated, and his estimates were fortunately better than more than what we estimated. So we come out from that dialogue easily. But yes, WBS estimates are normally challenged, because it's experts' opinion. If expert is not known or expertise is not established, the customer can challenge. Can function point be used for production support and maintenance supports? Very much. In fact, that's the only technique which can be used here. It is, as I said, there are three types of estimates. One is development, another is maintenance, and third is application. So when you take an application for maintenance, suppose a new application you are taking for maintenance, how do you decide that how many people you need to maintain this application? Based on function point. So you take the application, count the function point for this estimation for this application, and those function point will drive you to the number of people you need on the project. It can decently address the maintenance of the project. So yes, it is the best technique, or I think it is the only technique which can address the maintenance. Currently everywhere it is WBS is used, and in WBS, because you have not understood the application you have taken up, most of the places people have not understood the application they have taken up. They cannot assess the complete complexity of the things, and they often come out with the surprises. And initial phase of any application taking up for the maintenance is normally going into trouble. And the simple reason is that we are in the initial stage, we are not in the position to understand the real functionality and understand the complexity. And the best way to go to the function point, estimate the efforts, estimate the function point size. And if you know the size, you know how many people you need, and mostly they're going to be better. And you have an enhancement formula. You get those functionality and put into the enhancement formula, you will get to know that how much efforts you need to fix this particular thing, or to add this feature now into the application. That is the best one. But again, as I said, it takes more time than the WPS, and people are, and the problem is that the patience is normally in short supply. That's the real challenge here. Why cannot use latest technology in FP? You can use, that's what I said. It's a myth. People think that it is used for COBOL type of application. It is I and user talking about and say what user want, and I am assessing it. It has nothing to do with the technology altogether. Technology only come into picture when we talk about productivity, which will come into the end. So it is a myth that people don't know much about the FPA, but they create a perception that it cannot be used. Or sometimes it is simple excuse to not to use it, not to put efforts. Providing a message is also an element, like confirm error. Yes, it's also an element, but confirm an error, create one element only, not two elements. When we go into nitty-gritties of function point, then we come to these all things will be learned. So that's why the training is a must actually for FPA. Invalid age or invalid name, message or field of a screen is also an element. Yes, only if you are showing 10 type of error message for a particular, for one screen, you still count only one DET for error message. Any kind of error message, even if you have created 10 error messages. I think we are running out of time, but let me take some couple of more minutes if the people are okay with this. Even though we do our size estimate using FP, if a PM is preparing the project plan, he should be doing right. Even though we do our size estimate with FP, if a PM is preparing the project plan, he should be doing WBS right. There, yes, absolutely. WBS is a fundamental, is a fantastic thing for planning, not for estimating. Not for estimating. Qualifiers to arrive at the weightage for EI, EO and EQ complexity, is it standard? If so, who published it? This is done after a lot of research, and initially when Mr. Albrecht come out with this, they come out with these figures that these 3, 4. So these are based on basically on the analysis of the regression analysis of the previous projects, and that's why it is a parametric type of estimate actually, because the figures which we have come out, or formula we have come out, is based on the regression analysis of the previous projects. My organization uses WBS and FP both. It's good, but I think you should stop using WBS, use FP only. And there are many organizations where there is a standard, FP is a standard, no other things are used, only FPs are used. But for host application COBOL, they say it is difficult to use. No, I don't think so. It is basically when originated, it is actually applied for COBOL programs first time. It's not, I don't think it is true. COBOL has nothing to, COBOL, Java or .NET or mainframe has nothing to do with FP as such. FP is just assessing the functionality, estimating the functionality. I think there are 4 or 5 questions, and but we are running out of this. Okay, time. I will not take more time now. I think whatever your questions are here, be assured that all the questions will be answered. What I will do, I will send out the answer of these questions in an email to all of you. I know estimation is a kind of thing where always there are a lot of questions, and especially the FP, which is always a quiz for a lot of people. But I will stop here. We are running short of time, and I will answer all the questions. In few days you will get all the answers. Thank you very much to all of you for coming over here and participating here, asking these questions, listening to me. This is really great. And I hope today's webinar is useful to you and you will be able to use this knowledge in your project. And if you want this presentation, you can download this presentation. We will send you a link, but there is a little charges for this. There is a little cost to it, and that cost is your feedback basically. So if you provide the feedback before downloading this presentation, that will really be great. So what we will send you the link to feedback form. Once you fill up the feedback form, which will not take more than a minute, as soon as you submit the feedback form, you will be navigated to a page where you will find the link to download this presentation and you will get it. I hope you will not mind providing feedback. It will help us to improve our further future webinars, and I think you will enjoy more in future webinars. Thank you very much for being here. Really nice seeing you here. Be assured your questions will be answered. I have one hand being raised. Kushal Mangal. Kushal, you want to ask some question? You have, okay, he is left.